We are yet to start the walk. Okay, where did we stop in the last class?
Derivation of equations.
We derived already, all three derived. Did we do any numericals?
No.
So what should we do? Shall we complete the chapter and then do numericals, or we do numericals? One topic is remaining. What say? Complete the chapter. Okay. So the topic remaining is uniform circular motion. Okay, before that, if anybody has any doubt, all were present for last class. Everybody was present for last class. No. So have you gone through the video lecture? Yes. So anybody who is absent, okay, must go through the video lecture before attending the class. Otherwise, you will then not understand the discussion. But anyway, this is a new topic. It's called uniform circular motion. Okay, so anybody who misses the lecture, right, must go through the video lecture before attending the next class. Okay. Now, uniform circular motion, in short, it is also referred to as UCM. So, is it completed in anybody's school? This chapter completed? Yes? Okay. So, any idea what's UCM? UCM, uniform means constant. We have learned about uniform velocity. Anything uniform means constant, right? So something is constant in circular motion. So an object is undergoing circular motion, meaning it is going across a circular path. Let's say this is how it is going, right? So what is constant? Its speed is constant. So in UCM, okay, it is the name of the motion. Who goes this motion? The object. Let's say this object. Let's say Earth spinning around Sun. Okay, or Moon spinning, or Moon revolving around, not spinning. Earth revolving around Sun, or Moon revolving around Earth. Is in UCM, uniform circular. So in UCM, the speed of the object is constant. Is constant. Okay. So this is the feature of UCM. How do we describe UCM? So an object is said to be in UCM. In UCM, meaning uniform circular motion, when it moves along a circular path with constant speed. This is how you describe uniform circular motion. Okay, so this is one feature of UCM. What else? So when the object is moving in a circular path, so what is its direction? What is the direction? Direction is along the tangent. Okay. Did I tell you what is tangent?
Yes, sir.
Okay. So when did I tell you tangent? About what? Have we already discussed this?
No.
In what context did I tell you tangent?
So, in the context of the curve of the uniform motion,
Yes, that graph.
yeah.
Okay. So tangent is a perpendicular to the radius. Okay. So this is the radius. So this angle is 90 degrees. So if the motion is, let's say, anti-clockwise, the direction of the object is along the tangent all the time, right? And if this is the direction, Now I also told you, did I tell you that change of direction requires force? Are you aware? Like if I'm walking like this, I would better keep on walking like this unless somebody collides with me, then maybe my direction will change. Isn't it? Like if you're all familiar with carom, right? So when you strike the coin, after the strike it continues in a straight line path till it hits any other coin, right? So let's say the coin is hit in this direction. Let's say there was a coin sitting here. After hitting it, then maybe its direction changes. They both will have different direction, right? So meaning what? For change of direction, you require force. So at this point, if the direction was this, and if the body is moving in a circular path, that means over here its direction must have been this, by definition, correct? On a circular path, direction is always perpendicular to radius because it is along the tangent. So who changed the direction? Direction cannot change without any impact or force. So over here, the direction is in this direction. So this is another feature of UCM that it experiences a force towards center. It is called centripetal force. Okay? Nobody can move in circle unless it is experiencing force towards the circle of the circular path. Okay? Like in case of Earth or in case of Moon and Earth, okay, there is a gravitational force acting between Moon and Earth, which is always towards the center. Okay, so without centripetal force, UCM is not possible. So in UCM, the body experiences force towards the center of the circular path. The circular path. Okay. This force is called centripetal force. Centripetal means towards center. Centripetal. This force is called centripetal force. Okay. Now another property is so actually another point should have come before this. Now the speed is constant. What about the velocity? Is the velocity of the object in UCM constant?
No.
No? Why no? No is correct answer. Why no? Any idea? Anybody? Try. I mean, if it is wrong, it's fine. Try to explain. Why? You should be able to answer.
So I was not there in the class. I don't know.
Wonderful. Okay. So देखो अभी ये डायरेक्शन यहाँ पे है ठीक है. Now unless there is change of direction, it won't follow circular trajectory, right? So here the direction is changed here at every instant. At every instant, the direction is changing, right? So if the direction is changing, will velocity be constant? No, right? Because velocity is a vector quantity. It can change due to change of magnitude or change of direction or change of both. So in this case, speed is nothing but magnitude of velocity, right? But direction is not constant. Okay, therefore velocity is variable. So in UCM, the velocity of the object changes at every instant. due to change of direction. Okay. So its direction is always changing. That is why velocity is not constant. Okay. This is it. So write down all these things. These three are the features of uniform circular motion. Then we'll discuss some examples. What about the needle of the clock? Seconds needle of the clock. Is it an example of uniform motion? Yes.
Uniform circular motion.
Uniform circular motion. Correct. Is it an example of that?
Yes.
We are discussing examples of using. So every rotation or every revolution takes 1 minute. So speed is constant. Seconds. Or how long? Verification of the initial direction of the movements. First write down the sequence. You'll got the attendance sheet. Everybody is signed. Who has the movement? Yeah. Milan Shetty. Is he with us? Did he attend any class? You missed only one class, right? You missed only one class, last one.
Yes.
So you had attended till acceleration.
Yes.
Acceleration, huh? Graphs part you missed.
Sir, graph also.
Maybe you attended only distance time graph, ST graph.
Yes.
BT graph you missed.
Yes.
See. So verification of tangential direction of the object. Why are we saying that this object is moving along tangent? So that we need to verify. Okay. So everybody, yes, you can ask me which one. Huh? So Earth revolving around Sun, Earth revolving around Earth, motion of seconds, minute, or hour needle of the clock. All of them are example of UCM because they are taking the same time to complete a round. Okay. Okay. So the answer was correct. Last that question that you asked.
Oh, ma'am didn't give us the answer.
She didn't give us the answer. Did you give the answer? So how to verify? Did you discuss?
No, ma'am didn't discuss. Actually, no one solved the question.
Great. Shall we discuss?
Yes.
Some are still writing. Complete. Okay. So the experiment is, let's say, we have this textbook. Look at this activity. Person has tied a ball with a string, okay, and he is whirling the string like this. So, what will be the path of the ball? Circular, right? So you can see this that now if you leave it, while it is rotating, and when the ball comes in front of you, that's when you leave the string. Now, what is the path?
It will go here.
Huh?
Straight, it goes straight in the straight line.
Yes. So if I leave the ball when it is right in front of me, it will go straight along the tangent. Okay, you can see that it won't follow the circular path. That means what was rotating the ball in circular path? The muscular force which my finger was exerting on the thread, and because of that, a tension was getting developed in the thread and the ball. So that was always the case. So because of this force was in this direction, ball changed direction from tangent to this side. like that. Okay, because you can see the force moving from this side to this side to this side to this side all the time, right? Because what is the direction of the finger? Finger also you have to do like this, isn't it? That means when it is here, the force is in this direction, that way. Okay, but out here when it breaks, it will follow 10. Anywhere, if it breaks in this side, if the thread breaks here, then the ball will go straight. Okay, so that's the verification. Clear? So there are so many activities in your NCERT book, and many question comes on the activity. These are practical applications based questions. So do go through the activities mentioned. Okay. All right. Now we'll do the questions. Tell me what is the last numerical we did? The odometer वाला किया है हमने? The odometer of a car reads 2000 kilometers. That's the start of a trip. An object travels 16 meters in 4 seconds and another. What is the average speed? Let's do all the numericals. You have NCERT book? No? So I'll just read the numerical and I'll tell you the numerical number. You can go home and check. Those who have can open the book. Try to bring NCERT book as well as volume book. Every lecture of UT. Huh? Anybody from private CBSE? Like private CBSE, they don't follow NCERT till 8th standard.
Yeah, I was.
Private CBSE, but in 9th and 10th there is a government dictate that you have to follow NCERT. Now you are following NCERT. Okay, so this is NCERT first question of this chapter, right? Solved example 1. This is solved. Okay, so the first question is, I'll read the question. So listen to me carefully. An object travels 16 meters in 4 seconds, then another 16 meters in 2 seconds. Okay, so an object travels the length in 2 parts. This is 16 meters. This is also 16 meters. First 16 meter it takes 4 seconds. Second 16 meter it takes 2 seconds. Okay, this is the question. What is the average speed of the object? So, we will find average speed. This is the scenario. What should be the average speed? Shall I write all the formulas here?
We don't have this, right?
No, this was just an activity. Activities like you can write the activity number from the book. It's like if the string breaks, okay, it will follow this one. If the string breaks, it will follow this one. So what is the formula for average speed?
1
S1 plus S2 divided by T1 plus. Here you have only S1, S2, T1 and T2. So it is applicable for any number of distance. Total distance upon total distance. T2 divided by 6. 1.3, 5.3. Yes.
Like in this bus, the tree is continuously. So what are you supposed to do in that situation?
That's it. You can keep it up to 2. If it is greater than 5, then limit the answer up to 2 decimal places. Let's say you had a greater than 5 number, then this becomes 4. Okay, next question is, shall we discuss next one?
Yes, sir.
Okay, this is second solved example. The odometer of the car reads 2000 kilometers. Everybody understands what is odometer?
Yes, sir.
What is it?
That's what the kilometers travels by a car.
Shows the number, the kilometers.
The full kilometers covered so far, right? So that's odometer. So the meter, automobile meter has odometer and it has speedometer also. So the speedo is here, 0 and 20. Okay, that tells you kilometer per hour. Okay, and odo tells you distance covered. So there are 2 meters, 2 in 1 meter, right? Every automobile. So what it says is the odometer of the car reads 2000 kilometer at the start of a trip. 2000 kilometer at start. Okay, odometer reads. And 2004 kilometer at the end of the trip. At end. Okay, end of trip. If the trip took 8 hours, trip time. Equal to 8 hours. This is given. What do you have to find? Calculate the average speed of the car in kilometer per hour. This you have to find. Average speed. Same formula. Hang on. Huh? Got it? So how much you got? 50 kilometer per hour. So what is the distance here?
2400 minus.
Yes. So trip distance is 400 kilometers. Okay. And P is equal to data. So V average will be 400 by 8. 20. Okay. So same formula as in not exactly same. So the total distance now is 400, but now you're not getting it by adding. You're getting it by subtracting. So you have to understand the context of the question, how the question is asked. Okay? 2 different situations. Or there are certain in-text questions which are good for enhancing your conceptual understanding. Let's discuss this before going to the next question. So first question is distinguish between speed and velocity. You give me one difference. What is the difference between speed and velocity? Pass.
The velocity has a fixed direction and speed has fixed direction.
Velocity has a fixed direction and speed does not have a fixed direction. Correct? Correct?
Scalar.
Yes. Because speed is what kind of quantity? Scalar. And velocity is vector quantity. Okay. What else? Any other difference? Formula. Read the formula. What is the formula of speed? Distance upon time. What about velocity? Displacement upon time. These two differences. Third difference?
That speed is the average distance took and velocity is the average displacement.
That is covered in the formula, right?
Yeah.
Can speed be negative?
Yes.
Can speed be negative? No. Can velocity be negative?
Yes.
Yes. Because it depends on displacement. So these are 2, 3. So this is how you should be able to answer. Simple question, you know it also, but to be able to articulate it. Okay? So you need to discuss. Under what conditions is the magnitude of average velocity of an object equals its average speed?
Can you repeat the question?
Okay, I'll go slow. Under what conditions is the magnitude of average velocity of an object equals its average speed? Let me see more show of hands. No? Let her answer.
Distance and displacement are equal.
Okay, when that happens?
When
During uniform motion in a straight line.
Correct. In the same direction. When the direction is not changing. Okay. So uniform. The word uniform controls it. Uniform motion means it is in the straight line path and no change of direction. Because uniform motion means constant velocity, and constant velocity means its direction not changing. Okay. All right. What does the odometer of an automobile measure? We just said, huh? The distance traveled. Okay. What does the path of an object look like when it is in uniform motion? Listen to the question again. What does the path of an object look like when it is in uniform motion?
straight.
Straight line. Straight is the keyword. Okay. So keyword. Answer should carry keywords. It looks like a straight line. Okay. Fifth question. During an experiment, a signal from a spaceship reached the ground station in 5 minutes. What was the distance of the spaceship from the ground station? Okay, the signal travels at the speed of light, that is 3 into 10 raised to 8 meter per second. Okay, so this is an index question. This is not solved example. So I'm not giving it any number. So what is given is you have a spaceship. Okay, and it is sending a signal to a ground station. Okay, so it takes 5 minutes. Right, this is ground station. Spaceship is looking more like a satellite, so just excuse that. Okay. And at what speed it is sending the signal? 3 into 10 raised to 8 meter per second. So what you have to find? The distance, right? What was the distance of the spaceship? So you have to find the distance.
Not sure, but
Why are you not sure?
mostly it's the
How speed, time and distance related?
I think it is 50 15 into 10 raised to the power 8 meter.
So simple, right? V is equal to S upon T. Same formula. S is equal to V into T. Right? Average, it's just one data, right? So no question of average. So right now it is total distance is V into T. How much is T? 60 into 5. Okay. So how much it is?
900.
Into 3. So you got to be careful about the units. Here it is second. So you can't use it in minutes. Everything has to be 1 unit. It is a 9.
Instead of
Okay. This is how it should be. Okay, now let's come to the third example of NCRT, which is, yes,
Second question, second part is already there. Converted into meter per second.
okay, so meter per second is, what is kilometer? So this is kilometer per hour, right? Convert kilometer in meter. So 50 into 1000 meter. An hour is 60 into 60, which is 3600. Correct? 1 hour has 3600. So now, how much this would be? 2, 5, 7, 10, and 2, 18 times. So to convert anything from kilometer per hour to meter per second, what you should do? You should multiply it by 5 by 18. So kilometer per hour will be converted into meter per second. Right? So what is it now? Now solve it. 25 on 9. 125 by 9 meter per second. So how much is this? 9 on the 9? 35. More than 36. 14.1 meter per second. 14 or 13? Just divide it. Calculation. Divide by 18. 25. How much is this? Just divide and check it. 9 1 ja 9. 35. 9 4 ja 36. So it is 3. 27. 13 point something. 13.9. 9 4 times is 36. It is only 35. Okay. It has to. Yes. So everybody understood how to convert kilometer per hour into meter per second? To multiply by 5 by 18. And how did we get 5 by 18? Because kilometer is 1000 meter. An hour is 3600 second. So when you simplify, you get 5 by 18. 1000 by 3600 is 5 by 8. So this is a useful thing to know. Important. Kilometer per hour, meter per second is just multiply 5 by 8. The value in kilometer per hour you have to multiply by 5 by 18 to get value in meter per second. Okay? But when you multiply by 5 by 18, that time you don't have to write kilometer per 18. Right? It's like this. Multiplying by 5 by 18, okay, is when meter per second is mentioned. So we should not write it like this. We should write it kilometer per hour. When you multiply by 5 by 18, the answer is in meter per second. That one. Okay, next question. So this was in-text question. This was not solved example. Shall we discuss the next question?
Yes.
So Usha swims in a 90-meter long pool. So there is a 90-meter long pool. Okay. So swims like this. She covers 180 meter in 1 minute by swimming from one end to other and back. So she goes like this and comes back. Obviously 90 plus 90 is 180. S is equal to 180. 90 plus 90 is 180. So this is distance in one round trip, and the time taken for the trip is 1 minute. So this means 60 seconds. Okay, 180 meter in 1 minute by swimming from one end to the other and back along the same straight. Find the average speed and average velocity of motion. So you have to find average speed equal to what? And average velocity equal to. So average speed you have to calculate distance, and average velocity you have to calculate displacement. So average velocity I can tell you 0. Okay, 90 minus 90. So most of you got right. So average speed is so average speed is 90 plus 90, which is 180. 160. Three meter per second. The average velocity, this is average speed. Everybody understood?
Yes, sir.
Ninety minus 90, which is 0 by 60. This is the displacement. So you understood. Okay. So for displacement, this becomes minus. All right, I think. Do we have time still?